Hello students, how are you all? I hope you are studying regularly and working hard. So far in chemistry we have finished two chapters. First chapter was chemical reaction and equation and second chapter was your acid, bases and salt. Today we will start our chapter number 3 and that is metals and non-metals. Content of the chapter will be physical properties of metals and non-metals, chemical properties of metals and non-metals, formation of ionic compounds, properties of ionic compounds, extraction of metals, and corrosion. So, what are metals? Elements that are electropositive in nature are called metals. That is, they have a tendency to lose electrons and form positive ions. For example, copper, iron, aluminium, sodium, etc. Well, non-metals are the elements that are electronegative in nature. It means non-metals gain electrons to form negative ion. For example, iodine, sulfur, hydrogen, etc. Now, we will discuss physical properties of metals and non-metals. And we have made table which shows the physical properties of metals and non-metals and also compare them. First property is malleability. Metals are malleable, which means metal can be beaten into thin sheets, whereas non-metals are not malleable. For example, thin sheets of metals like gold and silver can easily be made. Second physical property which differentiate between metals and non-metal is ductility. Metals are ductile, which means they can be drawn into wires or wires can be made from them, whereas non-metals are non-ductile. Gold is the most ductile metal. Metals and non-metal can also be differentiated on basis of hardness. Metals are generally hard except a few, such as sodium and potassium, whereas non-metals exist in all three states, that is solid, liquid and gases, at room temperature. There is an exception when it comes to metal. Mercury is the only metal which exists in liquid form at room temperature. Fourth property which we will discuss is melting and boiling point. Most of the metal except sodium, potassium, mercury, cesium and gallium have high melting and boiling point, whereas non-metals have low melting and boiling point. But non-metals that are solid have comparatively higher boiling points or high boiling points. Next property is density. Metals have high density whereas non-metals have low density. Next is luster. Metals are lustrous, that is, they have bright shiny surfaces, whereas non-metals are not lustrous. For example, gold and silver are shiny metals. Seventh physical property is sonority. Metals are sonorous, they make sounds when hit by something hard, whereas non-metals are not sonorous. We can also differentiate between metals and non-metals on basis of thermal and electrical conductivity. Metals are good conductor of heat and electricity, whereas non-metals are poor conductor of heat and electricity. There are few exceptions in metal when it comes to thermal and electrical conductivity. Lead is a poor conductor of heat. Similarly, graphite, which is a non-metal, is a good conductor of electricity. So, physical properties of metals and non-metals is complete. And now we will discuss chemical properties of metals. First, reaction of metal with oxygen. Almost all metals combine with oxygen to form metal oxide, and generalized reaction is shown here. Metals react with oxygen to give metal oxide. For example, in this given reaction, copper reacts with oxygen to give copper oxide. Let's take few more examples. Sodium reacts with oxygen to give sodium oxide. Magnesium reacts with oxygen to give us magnesium oxide, and aluminium reacts with oxygen gives aluminium oxide. These metal oxides are basic in nature and most of them are insoluble in water. Some of them like sodium oxide, potassium oxide, calcium oxide dissolve in water and formed hydroxide called alkalis. Let's take example of sodium and potassium oxide. Sodium oxide react with water H2O to give NaOH, that is sodium hydroxide, which is an alkali. And potassium oxides react with water to give us potassium hydroxide. Next topic is amphoteric oxides. As the name suggests, these are the metallic oxide which shows property of acid as well as base. Aluminium oxide is an example of amphoteric oxides. Given below are two reactions, where in first reaction aluminium oxide is behaving like a base. Here it reacts with HCl to give us salt, aluminium chloride and water. And in example 2, aluminium oxide reacts with sodium hydroxide, which is a base or alkali, to give us a salt, sodium aluminate, that is NaAlO2, and water. Similarly, in our next slide, we have given example of zinc oxide behaving as acid and base. Zinc oxides when react with hydrochloric acid, behaving like a base and formed a salt, which is zinc chloride, and water. And when it reacts with sodium hydroxide, it behaves like an acid and formed sodium zincate, that is Na2ZnO2 with water. Okay students, now we will learn about the reactivity of different metals with oxygen. Some metal reacts vigorously or explosively with oxygen. For example, sodium and potassium, they are kept immersed in kerosene oil. Metals such as magnesium, aluminium, zinc and lead at ordinary temperature are covered with thin layer of their oxides. Iron does not burn on heating, but iron filings burns vigorously. Metals like silver and gold do not react with oxygen even at high temperature. Now we will learn about the process of anodizing. It is a process of forming a thick oxide layer on the surface of metal. For example, surface of aluminium is covered with thin layer of oxide. This oxide layer makes it resistant to further corrosion. So, how is anodizing done? Aluminium article which is to be anodized is put in the place of anode and is electrolyzed by dilute sulfuric acid. Oxygen gas is evolved at the anode and forms a thick protective layer of aluminium oxide on the article. This layer can be dyed easily to give it an attractive finish. Next is order of reactivity of metals with oxygen. It means which metal is more reactive towards oxygen. Sodium has higher affinity towards oxygen and silver has the least. Non-metals react with oxygen to form oxide which are generally acidic in nature. As you may recall, in the last chapter also we had discussed about it. So students, I think we have covered enough topics for single period, and in upcoming sessions we will cover the rest of the chapter. Watch the video carefully and go through your books also. And if any topic is missing in the video, let me know about it. And I will cover that topic in next session. Thank you and have a nice day.